So for section 5.8, our last section of chapter 5, we are going to apply special right triangles. So we are going to look at two different types of triangles. One is the 45, 45, 90 degree triangle, and the other one is the 30, 60, 90 degree triangle. So if we are given a 45, 45, 90, which means two of the angles are 45 degrees and the other one is a 90 degree angle, that the two legs are going to be the exact same length. And then the hypotenuse is that length, whatever that length is of the legs, times the square root of 2. So for example 1, we want to find the value of x. So the legs are the two sides that are coming off of the 90 degree angle. So if this one over here is 7, then so is this one. And our hypotenuse is that length, so 7 times the square root of 2. And that is the length of our hypotenuse in this particular triangle. And then here we have the side lengths, or the legs are x's, and the hypotenuse is 3. So we would take those side lengths, those legs, the x value, and multiply it by the square root of 2. And they're telling us that that side length is equal to 3. So remember, this is the length of the legs. This is always the square root of 2, and then this is the length of your hypotenuse. So now we have to solve for x. So what I'm going to do is divide by square root of 2, since this is multiplication right here. We're going to divide by the square root of 2. So this side would be x, and this would be 3 divided by the square root of 2. Now we can't have a radical left in the denominator, so what we're going to do is multiply by another square root of 2 over the square root of 2, because that would be equal to 1, and multiplying by 1 doesn't change our value, but it does help us alleviate that radical sign in the denominator. So at the top we have 3 times the square root of 2, so we're going to leave it like that. And then down here we have the square root of 2 times the square root of 2, which would be the square root of 4. 2 times 2 is 4. So, and the square root of 4 is actually 2. So our x value here is 3 square roots of 2 divided by 2. Example 2 says that Tessa wants to make a bandana for her dog by folding a square cloth into a 45, 45, 90 degree triangle. Her dog's neck has a circumference of about 32 centimeters. The folded bandana needs to be an extra 16 meters long so that Tessa can tie it around her dog's neck. What should the length of the square be? Round to the nearest centimeter. So if we add what they're giving us here, this is 48. 32 plus 8 plus 8 is 48. That is also the hypotenuse. So in a 45 degree, 90 degree triangle, we know that that side is also the leg length, which is L, times the square root of 2. So those two are going to be equal to each other. So we need to figure out what L is here by doing an upside down T. So I'm going to rewrite this over here. And I would have to divide by the square root of 2. These would cancel, so we'd have L. And this one says round to the nearest centimeter. So this means we're going to have to actually use our calculator and do 48 divided by the square root of 2. And when we do that, we're going to get roughly 34 centimeters. Moving on to the 30 degree, 60 degree, 90 degree triangle theorem. One of the legs is going to be S. The hypotenuse is going to be 2 times that length. And the other leg is going to be S times the square root of 3. So how do you know which leg is what in these problems? So it says the length of the hypotenuse is 2 times the length of the shortest leg. So S represents our shortest leg. And the length of the longer leg is the length of the leg times the square root of 3. So this shorter leg is involved, this S value right here is involved in the hypotenuse and the longer leg. So the hypotenuse is 2 times the length of that short leg, and the longer leg is that length times the square root of 3. So for example here, find the values of x and y and then give your answer in simplest form. So if you look in that triangle up above in the theorem, the 90 degree to 60 degree side is your shortest side there. So x is going to be our shortest side. And then 90 degree up to the 30 degree is going to be that length times the square root of 3. So y is actually going to be x times the square root of 3. And then 16, the hypotenuse, is 2 times that length. So using that piece of information, we are able to figure out 16 equals 2 times x. Well, then x must be 8. Because 2 times 8 is 16. So we figured out x. Now we have to figure out y. Well, y is over here, and we just said that it was x times the square root of 3. Well, we know now that x is 8. So 8 times the square root of 3. And the directions say to give your answer in simplest radical form. So we're not going to use a calculator. So we figured out that x was 8 and y was 8 square root. So we are going to use that to solve for x. So we're going to divide by the square root of 3. So we have 11 divided by the square root of 3 equals x. And then I can't have the square root of 3 at the bottom, so we're going to times by the square root of 3 over the square root of 3, because that's 1. So at the top, I'm going to have 11 square roots of 3. And at the bottom, 3 times 3 is 9. So that's the square root of 9, which is 3. So that's our x value. That's one answer. Then we have to figure out what y is. So y up here is equal to 2 times that value. So what we do is we multiply that number out front by 2. So y equals 22 square roots of 3 over 3. And our last example says the frame of the clock shown is an equilateral triangle. The length of one side of the frame is 20 centimeters. Will the clock fit on a shelf that is 18 centimeters below the shelf above it? So in other words, is this less than 18? So if it's an equilateral, all the sides are 20. And if I cut that bottom in half, we would have 10 and 10, right? So we have to figure out what this length is. So what happened here is when we divided that in half, we just made a 90-degree angle here. We took this was 60-degree angle, because an equilateral triangle, all the angles are 60. And then we divided this 60 at the top in half, so that would be a 30. So our shortest leg would be 10. And if we go back up to our theorem, our shortest leg is S, and that would be 10. Our hypotenuse is 2 times that, and then the other leg is that number times the square root of 3. I'm going to find my clock again. There. Ooh, don't want to do that. So this side is 2 times 10, which is correct. It's 20. We knew that. And then this side is going to be 10 times the square root of 3. So if I type that in my calculator, 10 times the square root of 3, I get roughly 17.3. So will it fit underneath or on the shelf that the other shelf is 18 centimeters higher than it? So it will, just barely. So yes, it will fit.